Have you ever wondered about the mysteries that lie in the vastness of the universe? This infinite expanse of space and time, with its galaxies, stars, and planets, is home to countless mysteries waiting to be unraveled. From the scorching heat of our boiling sun to the elusive gravitational waves and the enigmatic dark matter, there is a multitude of fascinating phenomena that beg exploration. Today, we're embarking on an extraordinary journey, delving into some of the most intriguing aspects of our cosmos. Prepare to have your mind blown with 25 incredible and interesting facts about our universe. Imagine a ball of fire, 1.3 million times the size of Earth. That's our sun. Let's dive into the sun, the burning heart of our solar system. It's an immense ball of hot plasma, a fourth state of matter that's neither solid, liquid, nor gas. This plasma is so hot, so intense, that it glows with a light so bright it can be seen from 93 million miles away. That's the distance from us here on Earth to the sun. The sun is a fiery furnace of fusion, where hydrogen atoms smash together to create helium. This process, known as nuclear fusion, unleashes an incredible amount of energy, causing temperatures in the sun's core to reach 15 million degrees Celsius. That's over 27 million degrees Fahrenheit. Hotter than anything we can naturally experience on Earth. Yet, this boiling ball of plasma isn't just a random assortment of hot gas. It's organized in layers. The core is the hottest part, where nuclear fusion happens. Surrounding the core is the radiative zone, where energy travels outward. Then comes the convective zone, where hot plasma rises and cooler plasma sinks, much like water boiling in a pot. The sun's surface, or photosphere, is where its light and heat escape into space. And finally, the corona, an outer layer that's mysteriously hotter than the surface, extending millions of kilometers into space. And do you want to know something truly humbling? The sun is just an average star in the grand scheme of things. There are stars out there that are hundreds of times larger and millions of times brighter. But despite its average size, the sun holds a special place in our hearts, or rather, our solar system. It's our source of light and heat, the engine that drives life on Earth. So next time you look up at the sun, remember you're staring at a boiling ball of plasma, millions of times the size of our planet. Did you know that space can ripple like a pond? Yes, it's true, and these ripples are called gravitational waves. They're invisible ripples in space-time, which is the four-dimensional fabric that Einstein's theory of relativity tells us makes up our universe. These waves are produced when massive objects accelerate or decelerate. Think about two black holes spiraling towards each other, or a supernova explosion. These cosmic events cause such a dramatic disturbance that they send out waves, much like how a thrown stone causes ripples to spread out across the surface of a pond. The discovery of gravitational waves is a relatively recent event. It was in the year 2016 that scientists first detected these waves, a full century after Einstein predicted their existence. The detection was made by the Laser Interferometer Gravitational Wave Observatory, or LIGO for short. But why are these waves so significant? Well, they provide a completely new way of observing the universe. You see, before the detection of gravitational waves, we were limited to observing the universe through electromagnetic radiation, like light and radio waves. But gravitational waves give us a new tool, allowing us to probe cosmic events that would otherwise be invisible. For instance, the collision of two black holes, which produced the first detected gravitational waves, could not have been observed with traditional telescopes. The event was completely dark. No light was emitted. But the gravitational waves it produced gave us a window into this dramatic event, providing a wealth of information about the nature of black holes. The study of gravitational waves is a booming field in astronomy, with new discoveries being made regularly. It's an exciting time, and who knows what we will uncover next as we continue to explore the ripples in the fabric of space-time. Just as a stone thrown into a pond causes ripples, so do massive cosmic events cause ripples in the fabric of space-time. Have you ever heard of the cosmic superhighway? Well, in the realm of space exploration, it's known as the Interplanetary Transport Network, or ITN. This fascinating concept is an invisible network of pathways that exist in our solar system, where the gravitational pull from different planets and celestial bodies balances out. Just imagine, rather than burning huge amounts of fuel to propel ourselves through space, we could hitch a ride on these gravity-assisted highways. It's a bit like catching a train, but in this case, the train is the natural forces of the universe. and the journey is a celestial adventure. The ITN works by taking advantage of Lagrange points. These are locations in space where the gravitational forces of a two-body system, like the Earth and the Moon, produce enhanced regions of attraction and repulsion. These points allow spacecraft to move around the solar system with very little energy required, almost as if they're coasting along a cosmic highway. But how do we find these cosmic pathways? It's all about the math. Scientists use complex calculations to map out these highways, determining the most efficient routes for spacecraft to take. It's like using a celestial GPS. The potential applications of the ITN are tremendous. For example, it could revolutionize the way we explore our solar system and beyond. A mission to Mars, the outer planets, or even interstellar space could be made far more feasible and cost-effective using these cosmic highways. Of course, there are challenges. The ITN is slow, and a journey that takes a few months with traditional rocket propulsion could take years or even decades using the ITN. But as we develop new technologies and improve our understanding of the universe, it's possible that we could find ways to overcome these challenges. So the next time you look up at the stars, remember that there's a network of cosmic highways out there just waiting to be explored. This cosmic superhighway could be the key to exploring the far reaches of our solar system and beyond. What if I told you that there is a mysterious substance that makes up 85% of the universe, but we can't see it? Let's delve into the enigmatic world of dark matter, a concept that has both befuddled and fascinated scientists for decades. Dark matter, as the name suggests, is dark. It doesn't emit, reflect, or absorb light, making it virtually invisible. But if we can't see it, how do we even know it exists? Well, it's all about the gravitational effects. When Swiss astronomer Fritz Zwicky observed galaxies in the 1930s, he noticed they were spinning far too quickly, so much so that the gravity produced by their visible matter couldn't possibly hold them together. There had to be something else, something invisible, providing the extra gravity. He termed this unseen substance dark matter. Fast forward to today, and we still haven't directly detected dark matter, but its presence is inferred in other ways. For instance, the way galaxies cluster together on large scales, or the bending of light from distant galaxies as it passes closer ones, a phenomenon known as gravitational lensing, can't be explained without invoking dark matter. Despite this evidence, dark matter remains elusive. We're not sure what it's made of. The leading candidate is a new type of particle, the weakly interacting massive particle, or WIMP. But as of now, this is purely theoretical. No experiment has yet detected a WIMP. So why does dark matter matter? It plays a crucial role in the formation and evolution of galaxies. Without dark matter, it's likely that galaxies wouldn't have formed at all. It's the gravitational glue that holds galaxies together, and the scaffolding upon which they are built. The mystery of dark matter continues to baffle scientists, but its existence is a cornerstone in our understanding of the universe. Despite its enigmatic nature, it underscores a key aspect of science. There's always more to discover, always more questions to answer. So, until the day we unravel the secrets of dark matter, it remains one of the universe's most profound mysteries. Despite its massive size and high temperature, did you know that the sun is surprisingly inefficient? It seems counterintuitive, right? The sun, this colossal ball of burning gas, provides us with all the light and heat that we need to survive on Earth. But when you delve into the science of how the sun generates energy, the picture becomes a bit more complex. Let's start with the basics. The sun's energy comes from a process called nuclear fusion. This is when hydrogen atoms in the sun's core combine to form helium. This process releases a tremendous amount of energy in the form of light and heat. But here's the catch. The sun's core is so dense and hot that it takes an incredibly long time for the energy produced in the core to reach the surface of the sun. We're talking millions of years here. All this while, the energy bounces around inside the sun, losing a significant portion of its initial energy before it finally makes its way to the surface. Moreover, the process of nuclear fusion itself is not particularly efficient. Only a tiny fraction of the sun's hydrogen is involved in fusion at any given time. In fact, it's estimated that only about 0.5% of the sun's total mass has been converted into energy over its 4.5 billion year lifespan. To put it in perspective, if the sun were a car, it would be like driving 100 miles on a tank of gas that could theoretically take you around the world twice over. That's how inefficient the sun is as an energy source. But despite this inefficiency, The sun's vast size and the sheer scale of its energy production mean we receive more than enough energy to power our planet. It's a testament to the sheer abundance of the universe that we can thrive on the leftovers of such a wasteful process. The sun, while being our primary source of energy, is a rather inefficient one at that. The universe is truly a fascinating place, full of mysteries and wonders. We've journeyed through the boiling sun, felt the ripples of gravitational waves, navigated the interplanetary transport network, and delved into the enigmas of dark matter. We've even questioned the sun's efficiency as an energy source. These 25 incredible facts remind us of the universe's vastness and complexity. As we continue to explore and understand, remember, the universe is not just about stars and galaxies, it's about the incredible physics and mysteries that lie in its vast expanse.